In this video, we're going to name some organic compounds and go over some things about nomenclature. So to begin with, we need to be familiar with the names of some common alkanes. So if you have an alkane with one carbon, that's methane. If you have an alkane with two carbons, that's ethane or ethane. And as we go down the list, it's going to be propane, butane, pentane. That right there is not in the right spot. Hexane. We got heptane, and then we have octane, nonane for 9, and then 10 you have decane. So make sure you have that list memorized. Also for that list, let me just bring it back. If you have a substituent that has the same number of carbons as these, what you would do is take away, so for example, if you had a substituent with one carbon, instead of methane, take away the A and E and put methyl. Same thing for two carbons, ethyl, propyl, all of that. So now let's go over our first example. So let's go over how would you name this compound? So in the main chain, we have 4 carbons. So the end of the name of this is going to be called a butane. And we have 2 substituents. We have a methane, not a methane, my bad, a methyl on the second carbon and another methyl on the third carbon. So whenever you have 2 substituents, you're going to indicate the position of them on the chain. So one is on carbon. If you want to count the carbons, you can do so. So the first one is on carbon 2, the second one is on carbon 3. You put a dash, and then since it's 2 methyls, you're going to put the prefix dimethyl, and then this is all going to be one word. So give this one a try. Feel free to pause the video. So first thing we need to do is count the longest chain. The longest chain is actually not this, it's actually this. Even though you have to turn 90 degrees right here, this is still the longest chain because you have the largest number of carbons next to one another. So if you count the number of carbons, 1, 2, 3, 4, 5. Now, which way do we count? Do we count from this way or that way? So because this substituent is going to be having a lower number than this one, from this end, we're going to count the way I just did. So we have 5 carbons, which is pentane, and then we have a methyl on carbon 2, and we have a methyl on carbon 3. So that's going to be 2,3-dimethyl once again. This time it's going to be a pentane. Next example, let's take a look at CH, CH2, CH2, CH3. How would you name this compound? So if we count the longest chain or we find it, it's going to be this right here. So there's one substituent. Now, do we start counting like this, or do we count from left to right? What do you think? So we're actually going to count the way the red is, because then the substituent, which is this methyl, is going to be on carbon number 2, as opposed to it being on carbon number 4. So we always want the lowest number of substituents. So that's how we're going to count. Now we have 1, 2, 3, 4, 5. We have 5 carbons in the main chain, so that's a pentane. And then we have a 2 methyl, because we have a methyl on the second carbon. Now let's take a look at a more complicated example. So H3C, CH2, CH, CH3, and then attached to that CH is something else. So finding the longest chain is a little bit complicated, but it's not too hard. So you're going to start right here, and if you go like that, you have 4 carbons. But if you go like this, you have 5 carbons. So that's how we're going to count the longest chain. You could do it this way as well, and you get the exact same outcome. But let's go with this approach. So if this is our main chain, how are we going to count it? Are we going to count it this way, or are we going to count it that way? So if we count it from left to right, the substituents are going to be on carbon 3 and 4. But if we count from right to left, the substituents are going to be on carbons 2 and 3. So we want the lower ones, so we're going to count the 2 and 3 option, which is the one from right to left. So we have 5 carbons, which is a pentane, and then we have substituents. We have 2 methyls on 2 and 3. So this is 2,3 dimethylpentane. Now let's move on to bond line structures. What this structure means is that at each intersection there's going to be 1 carbon, and then the carbons are not just there the only thing. So this one has 2 bonds, but the carbon obviously needs 4, so there's 2 hydrogens right here, but we don't draw it because it obviously takes too long. This place right here has 1 bond to the carbon, but carbon usually has 4 bonds, so the 3 hydrogens are going to be there, but they're left out. So knowing that, we have 1, 2, 3, 4, 5 carbons in the main chain. So that's called, once again, pentane. And we have a substituent, a methyl, coming off of carbon 2. So 2-methylpentane is the name for this one. To count the longest chain, you may think that this is the longest chain because that just looks like it. It's straight. However, the longest chain is going to be here. It looks like this is an ethyl substituent, but it's not. It's actually part of the main chain. So be careful with those questions because that's basically the oldest trick in the book in organic chemistry, to getting you to get the question wrong. So the main chain has 6 carbons, and we have a methyl on carbon 3. So a methyl on carbon 3 is 3-methyl, and since we have 6 carbons, that's called a hexane. So that's the name for this one. Next example, we're going to have this, and then how would we do this example? So to make it so that we have the lowest numbers, we're going to count left to right as opposed to right to left. And we get another hexane because we have 6 carbons. And we have 4 ethyl, 2 methyl. However, which one do we write first? We have a 4 ethyl and we have a 2 methyl. Do we write the methyl first because the numbers comes first, or do we put ethyl first because E comes before M in the alphabet? So we're going to actually go by the alphabet and alphabetize these substituents. So it's going to be 4 ethyl first because ethyl, the E comes before M, and then 2 methyl hexane. Next example, let's take a look at another compound. And then on the 4th carbon, we're going to have so how do we name this compound? So first of all, we have to find the main chain. Once again, as I said before, it may look like this is the main chain. It really looks like it, but the main chain is actually going to be here. So when you look at this intersection, this carbon, you obviously don't go here because that's just 1 carbon. You have 2 here, but you have 3 here, right? You have 1, 2, 3 here. You want to choose the longest one, so this is the main chain. Now in terms of counting the carbons, we're going to start counting from here because then our substituents would be on 4. If we start counting here from the left, our substituents would also be on 4. So, what do we do in this case? Well, in this case, all of our substituents are on carbon 4, so it actually wouldn't make a difference. Yeah, it really wouldn't make a difference. But there are cases where it does make a difference, and we will go over some examples that are like that. But if your molecule is symmetric, then it won't matter. So you can count either way. Let's just do the blue way because we did it first. We're going to have 7 carbons in total in the main chain, so that's called a heptane. And on carbon 4 we have an ethyl and we have a methyl. So it's going to be 4 ethyl, 4 methyl heptane. Go ahead and try this example. Actually, don't. Let's change that. I think that's a better example. So, in this case, the main chain can either be this, or it can be this. it won't make a difference. But let's just go with the first one because it makes visualizing it easier. Right. So these are our substituents. We have a methyl and we have an ethyl. Now, which way should we count? Should we count from right to left or left to right? What do you think? If we start counting from left to right, we're going to get a 3-methyl and a 5-ethyl. If we count right to left, we're going to get a 3-ethyl and a 5-methyl. Which one do we want? So we know that when we write the name, the ethyl is going to come first before the methyl because E is before M in the alphabet. Therefore, we also want the numbers to be in increasing order. So it's better to have 3, which is the lower number, on ethyl, which comes first in the name, than to have it second. So I'm going to write both alternatives so you can see what I mean. So if we were to go the red way, it would be 3-ethyl, 5-methyl, and then we have a heptane. If I were to go left to right on the blue way, it would be 5-methyl, it'd be 5-ethyl, 3-methyl, heptane. If it's not going to make a difference in terms of the numbers on your chain, then you want to alphabetize it when possible. So we've already alphabetized it, but you want it to be in increasing number order if you can do that. So in this case we can, so that's how we count. So the red option would be the best answer in this situation. So in this example, we have, in the main chain, we have a butane, and then we have 2 substituents, so it's going to be 2,3-dimethylbutane. Next example, we're going to have 6 carbons in the main chain, so then we have 1 carbon coming out here. How do we name this molecule? Go ahead and give it a try. So we have 6 carbons in the main chain, which is a hexane. We have 3 methyls, so one's going to be on carbon 2, 3, and 4. So one's going to be on 2, 3, 4. We're going to put trimethyl as our suffix this time, and then hexane. In this situation, the molecule is symmetrical, meaning that whether you count from right or left, it's not going to make a difference. It's the same on both sides. Therefore, if you count the longest chain, you can just say we have 5 in the longest chain. So that's going to be pentane. And we have 4 substituents. We have 2 ethyls on carbon 2, two methyls on carbon 2 and 2 methyls on carbon 4. So this would be a 2,2,4,4, and for the prefix for 4 is tetra, and I ran out of space here, so I'm going to move that, tetramethylpentane. So now I'm going to move back to condensed structures for a minute, because this is a tricky one. So how do we name this weird looking hydrocarbon? The first thing you need to realize is that you have to count the longest chain. That's always our first job. So if you look at it, start from the left and kind of go here. You have two options when you get to this carbon. You can go here or you can go here. Both options are going to be the same because you have 3 carbons on each. So those are propyl groups. So it's not going to make a difference which route you go down. So most straightforward way is to go as this here, so that it looks it looks like the main chain is in one line, which makes having mistakes less likely to happen. Do we start counting from left to right though, or right to left? So it looks like we're going to start counting left to right because that would give the substituents the lowest number. So 1, 2, 3, 4, 5, 6, 7. So we have 7 carbons, which is heptane. We have a methyl on 3, so that's a 3-methyl. And then we have a propyl, which is 3 carbons like this on number 4. So 3-methyl, 4 propyl heptane. So now let's look at another example where we're going to have a molecule we haven't seen before. So first thing you want to do when you see something like this, you could expand it out just so it'd make it easier to understand. So we have a CH3, then we have a CH2, then we have a Cl. Now we have 2 carbons, which is associated with ethane. But more importantly, we have a substituent, which is chlorine. So how are we going to name chlorine? Chlorine is known as, when you put it as a substituent in a name, it's going to be chloro. And actually, I don't think there's a U in there. That's only for fluorine. So chloroethane is the name way you name that. You don't have to put a number on it because even if the chlorine was on the other carbon, you could just count the other way around and the carbon would be 1. So either way, it's not going to make a difference. How about this example? How do we do this one? So in this one we can expand it out just to make understanding of it easier. CH3 on the left. We have a CH2, we have another CH2, and then at the end we have a fluorine. The fluorine, when you put it as a substituent, is going to be fluoro. 3 carbons, that means we have a propane. In this case, we do need to specify that the fluorine is on carbon number 1 because it could be on carbon number 2 as well. So 1-fluoropropane is the name of this haloalkane. So whenever you have halogens attached to a carbon, that's going to be a haloalkane. Now, alkanes can also be bromines and iodines and chlorines. This situation we have CH3, CH, Br, CH3. How do we name this one? The CH3 on the left, so if you want to draw it, it'd just be like this. We have a CH, then we have the end with a methyl. So in this case, we have again 3 carbons, which is a propane. And then the bromine, notice how it's on carbon number 2, it's in the middle. If it was on the side, one of these carbons would be 1. So in this case, we have a 2-bromo propane. How about this example? How would we do this one? If you want to count the longest chain, it would be this, but how many carbons do you actually have in it? So there's one right here. At this intersection, there's one, so this is the second carbon. At this intersection, there's a third carbon. Fourth carbon is here, and fifth carbon is there. So main chain, we have a pentane. Now, we have 2 substituents. Both of them are methyls. One methyl is on carbon 2, the other one is on carbon 3. So that'd be a 2,3-dimethyl pentane. For our last example in this video, let's draw a similar structure. Let's draw H3C. How would we name this compound? So what we have here, again, if we want to count the longest chain, it would be here. You have carbon 1, carbon 2, 3, 4, 5. So once again, pentane. Now the question becomes, do we start counting from left to right or right to left? So in these cases, just like we had before, we want the lowest number to be on the substituent that comes first in the alphabet. So in this case, we have a methyl, M. We have a chloro, C. If we count right to left, we're going to have numbers 2 and 4. If we count left to right, we're still going to have 2 and 4 for our substituents. So because of that, we're going to go by the alphabet. So we're going to prioritize the chloro because C comes before M in the alphabet. So we're going to count left to right. So we'd get 2-chloro, 4-methylpentane. So that's the video. I hope it was helpful, and thank you for watching.